Okay,
I know.
let's try this. We want to do number 16, or number 35 out of 16.4, which is there are two circles, each of radius 1. The centers are 1 unit apart. We want to find the area of intersection. So we should see if we can write down a formula for this area. Of course, they didn't give me any coordinates or anything, right? So I get to make some up.
That one's AB.
Dear God, don't do that.
I like doing a cylindrical.
Okay,
Well, it's
also-
it's a double an integral.
It's 2D, right?
It's a
So I
polar.
don't need cylindrical, but polar or Cartesian, probably polar, right?
But it asks us to get both.
Okay, it asks for both, set up both of these. But I need some coordinate axes to start anything at all. So where do you want to put 0? Right? You get to pick where you put the origin.
The center of the left disc.
Yeah.
Okay. So you want to put the origin here, and you want to do axes like this,
Yeah.
Yeah.
X
Then
and
we have
Y.
our nice little radius.
Okay, so this circle, right, is what equation? The left disk is given by
X squared plus Y squared. And then there's a
is
shift.
1, or, Donald, what was your,
That can just be our radius bound.
right? You guys see that? The left disk is x squared plus y squared is 1, or in polar, right, it's r is 1. Cool?
Okay.
Really, maybe r squared is 1, but whatever. Okay, how about the other disk?
X minus 1 squared because of the
X minus 1 squared
Plus y squared
plus y squared
equals 1.
is 1. Does that check out?
yeah.
I wanted a right shift 1 unit, so I subtracted 1 from the x. Yeah, that seems to jive. Cool.
But,
So that's in Cartesian, right?
yeah.
Can
Okay.
you make them equal each other?
Okay, that would give me these 2 points, right?
Yeah.
You guys see that?
Mm,
Okay, so where are those?
Do they matter?
what?
Do they matter?
Yeah. Sort of.
Convince me one way or the other.
Aren't they your
That's not convincing. That's not what convince me means.
Well, because aren't we trying to find the volume of that center thing?
I'm trying to find the area of the
Yeah,
center
yeah,
thing, yeah.
Okay, so
those are your
wouldn't
bounds.
that be the integral bounds?
Yeah.
So those are the integral bounds if I'm doing
in terms of
Cartesian.
Cartesian.
Cartesian. Those are my,
X values.
X.
Oh, Y values.
yeah, those are the y bounds, right? So if I did dx first, those would be the ends on the y.
Mm.
So yeah, I think we need to find them. Okay, so how do I find this?
X squared plus y squared equals x minus 1 squared plus y squared.
Okay, so that's where these two things intersect, right? And they're both equal to 1, so I can set x minus 1 squared plus y squared equals x squared plus y squared.
Okay.
And I think we can cancel some
Y squareds.
y squareds.
You have to expand the X minus 1 squared.
Okay, so I've got x squared minus 2x plus 1 is x squared.
X squares cancel.
X squareds cancel, and I get x is...
1/2.
Oh, that was kind of derpy of me, wasn't it?
Well, negative.
Did I need to know that? Did I need to go through all that, Jess?
No.
No,
Negative.
it's halfway in between, right? Duh.
Oh, yeah.
Cool. So those are the x's. So what are the y's there?
Y's would also be 1/2.
Uh-uh.
Oh, no. Oh, wait.
So they're 1/2.
Squared.
What?
Yeah.
Oh, you have your substitute. Okay.
Square root of 2.
So you gotta
Root 3 over 2.
Square root of 3 over 2. Oh, did you say it's square root of 3? I thought you said square root of 2.
I said that first.
My bad. Alright, so now I found those points. This one being, of course, 1/2 comma
Negative root 3.
negative square root of 3 over 2. Don't forget your plus or minus, right? There's two of them. Okay, so Cartesian. Can I set up a Cartesian integral for this thing? Double integral of what?
One.
Do you have a density?
No.
No, you're trying to find an area, right?
Yeah.
So 1.
Yeah.
The
Doesn't matter. I don't believe.
I like DX.
Yeah, dx.
I like dx dy too, so that I don't have to split it into two pieces, right? Because the y's start, well, if you're over here, they start there and end here, and over here they start here and end there. But if I do the x's, I can just go straight across.
And then the y's all straight down.
Okay, so the x's go from
0 to 1.
X. 0 to. No.
They go from the right circle to the left circle.
Yeah.
yeah, they go from the edge of the right circle to the edge of the left circle.
Which
See that?
isn't it 0 to 1? No.
No, because 0 to
'Cause it
1
could
would
be
give
a-
me this whole square, right?
Yeah.
So if I
You could
slice the
change
x's, right, they look like this.
Okay, so
So they start over here on this thing and end over there. So I need to solve those guys for x, right?
Okay. So then that would just. that
So-
would-
This one at least is easy.
Why are
Solving-
you saying right to left? Isn't it left to right?
It's the right circle
Edge.
to the left
Thank
circle.
you. Okay.
Yeah, it is from left to right. But yeah.
So x.
So we have.
Okay, so this is x squared is 1 minus y squared, right?
Mhm.
So this would tell you x is plus or minus
Square root
Square root
of 1
of-
minus y squared.
square root of 1 minus y squared.
Mhm.
And we need the left half,
And I need
or
the
the right half of that.
right half of that one for the top bound.
Yeah.
So that's here, square root of 1 minus y squared.
and the
The bottom one.
Okay, and the other one's a little bit more annoying. This is x minus 1 squared is 1 minus y squared. So x minus 1 is the plus or minus the square root of 1 minus y squared.
Plus.
So 1.
So throw a 1 on there.
Yeah.
So that starts at
1 minus.
1 minus the square root of 1 minus y squared. Perfect. And then where do your y's go? What are your bounds on y?
Negative.
Half to 1.
Negative root 3 to 2.
Oh, yeah.
Negative square root of 3 over 2 to
Root 3 over 2.
positive square root of 3 over 2. Is that integration you want to do particularly? Nah, it's kind of nasty, right?
Yeah.
What's that going to result in? For
Trig
sure.
sub.
100% trig
Trig
sub,
subs.
right? Okay. You could exploit symmetry a little bit, right? And not do 2 trig subs. You could get away with just 1. But.
So why don't we
Make
do dy
poles.
first again?
So I did
X.
dx first because I wanted to go consistently from a left side to a right side. If I did the dy, I'd be looking for slices this way. And there's 2 different options, right?
Yeah.
This one starts at the bottom here and ends at the top there. And these ones start at the bottom of a different function and end at the top of a different function.
Oh, okay. Yeah.
Really, it's not even a function, but
Yeah.
you guys see that? So you'd have to split it into 2 pieces.
And add them up.
Of course, they're the same size, so you could exploit symmetry a little bit. Right? But all right, should we try it in polar?
Yeah.